We continue today about mid-segment theorem. This part will talk about trapezoid, which is a new quadrilateral, special trapezoid, how to prove a trapezoid, and mid-segment theorem and a trapezoid. First, what is a trapezoid? It's a quadrilateral such that it has exactly two parallel sides. Like in this figure, we have AB and CD, two parallel sides only. The two other sides, AD and BC, must not be parallel. If they are parallel, then we will have a parallelogram. So, in order to have a trapezoid, we need only two parallel sides exactly. One side will be smaller than the other from the two parallel sides. So, in this case, AB is a small one. It's called base. It's the small base. BC is the big base. They are parallel, of course. The diagonals are AC and BD. The distance between the two bases is the height. We name it the height of the trapezoid. Now the area of trapezoid, how to find the area? It's equal to the big base plus small base, all multiplied by height over 2. We will do a small example after a while. Now we have some special trapezoids. Right trapezoid, for example. Simply, it has two right angles. Okay, so we call it a right trapezoid. In this case, since we have two right angles, of course, the distance between AB and DC is this side, AD. So it's the height. AD is the height. So if we want to calculate the area, it's AB, small base, plus DC, big base, all multiplied by AD, the height, over isosceles trapezoid. Isosceles trapezoid is the second type, particular case of trapezoid. In this case, or in this trapezoid, in this special trapezoid, we have two sides. The sides that are not parallel are equal. The angles at each base means that at the big base we have two angles. They are equal. The angles at the small base also are equal. The diagonals, like DB and AC, are equal. And also we have one perpendicular bisector for the two bases. So the two bases, AB and DC, has only one perpendicular bisector, the same perpendicular bisector. So it's an isosceles trapezoid. How to prove a trapezoid? We know how to prove a parallelogram, a square, a triangle, a rhombus. Now we will know how to prove a trapezoid. So simply, if we have a quadrilateral such that this quadrilateral has only two parallel sides, exactly two parallel sides, we will call it a trapezoid. It's very simple. So we must have exactly two parallel sides. Now how to prove special trapezoids? First, how to prove a right trapezoid? Simply, we need a trapezoid and one right angle. Means that we prove first it's a trapezoid, then we find one right angle. Now to prove an isosceles trapezoid, also first we prove it as a trapezoid, then one of the following, not all of them. For example, we prove it a trapezoid and having angles at any base equal. That's enough, it's an isosceles trapezoid. Or trapezoid and non-parallel sides are equal, so it's an isosceles trapezoid. Or trapezoid and equal diagonals, also it will be an isosceles trapezoid. In this example, we have this figure, given that AB is an isosceles triangle, AB is parallel to CD. The question is, what is the nature of quadrilateral ABBC? First, it's very clear, since AB and CD are parallel by given, and also it's clear that AC and BD are not parallel, so it's a trapezoid. That's first. But pay attention, because it could be isosceles trapezoid. It's obvious it's not right, but it can be isosceles. So we must find out if it's an isosceles trapezoid or not. Here we have NAB and NCD, the two angles here, A, NAB, and C, are equal because they are corresponding angles, since we have AB and CD are parallel. Also on this part, we have the angle B and BA and the angle D are also corresponding, so they are equal. But we know that NAB and NBA are equal because they are two angles at the base of an isosceles triangle. So if we write it, we will notice that by substitution, we will deduce that NCD and NBC are equal. Okay, so NAB and NCD are equal, NBA and NBC are equal. These two angles are the same, they are equal. So these two angles also are equal. And we have two angles at the base of this trapezoid and are equal. Then it's an isosceles trapezoid. The segment theorem in a trapezoid. If we have a trapezoid, as you already know, the mid-segment theorem consists of midpoints. So we need two midpoints to say that we have a mid-segment theorem. Also in trapezoid, same idea as in triangle. If we have a trapezoid, for example, ABCD, E is the midpoint of AD, F is the midpoint of BC. EF, the segment joining the midpoints of the trapezoid, is called mid-segment of the trapezoid. This mid-segment, according to the mid-segment theorem, is equal. First, it's parallel to the bases, it's parallel to AB and parallel to DC, and it's equal to the sum of the two bases over 2. Okay, so this is the mid-segment theorem in trapezoid. Two midpoints, so we have a mid-segment. This mid-segment is parallel to the bases, plus it's equal to big base plus small base over 2. In this trapezoid, EF equal AB plus DC over 2. Also, we have an example. In this trapezoid, we have the small base 4 cm, the big base 8 cm, E midpoint of AD and F midpoint of BC. So EF is the mid-segment of this trapezoid. So to find the value of EF using the mid-segment theorem, it's equal to the sum of the bases, 4 plus 8, over 2 divided by 2 will be equal 6 cm. Please study well and do your homework.